Good morning, Year 7. Today we're going to be learning about pi and the circumference of circles. First of all, we want to be able to name different parts of the circle. So the first part we want to learn about is the diameter. The diameter can be called lowercase letter d. It is the distance across the circle going through the center. And we're going to draw all of these in a diagram down the bottom of all this. Next we have the radius. The radius is given the symbol little r. It is the distance from the center of the circle to the edge, and it says there to note that 2 lots of the radius is equal to the diameter. A chord is a line interval connecting 2 points a circle. So it's a bit like a diameter in that it goes from one side of a circle to the other, but the diameter has to go through the center where a chord does not. A tangent is a line that touches the circle at a point. A tangent to a circle is at right angles to the radius. A sector is a portion of a circle enclosed by 2 radii. Radii is the plural for radius, and a portion of the circle arc. Okay, it's a bit like a piece of pizza, like a wedge of the circle. A segment is an area cut off by a chord. And we're going to be calculating the circumference, which is given the letter C, and it is found distance around a circle. So it's really a special name for the perimeter of a circle. There are 2 formulas to find the circumference of a circle, and they're here in this box. And the formula that you use depends on what you're given in the question. If you are given the radius, then you're going to use the formula that has a r for radius in it. If you're given the diameter, then you're going to use the formula that has a d for diameter in it. So the formula for radius is c equals 2 pi r, and the formula, if you have the diameter, is c equals pi d. Now, pi is a symbol that we haven't really used before in maths. It is a constant numerical value. We give it the Greek letter pi, which is a wiggly top like that, and 2 straight lines. That's how we draw it. And it is an irrational number, meaning that it cannot be written as a fraction. Now, to see the value of pi, it is a decimal. The digits have no pattern and they continue forever. But we can use our calculator to see the first quite a few places. So if on my calculator here I press the shift button and then right down the bottom, this times 10 to the x, you see the pi symbol come up. You press equals and there's the first maybe 10-ish decimal places of pi. But as we've said, that number, which there is no pattern to, would continue forever. There is no end to the number. It cannot be written as a fraction, which is why we call it irrational. Now, the reason we have this number was because it was found experimentally at first that if you wanted to find the circumference of a circle, you would multiply by this number by the diameter, or the formula that's written here in our booklet is that the circumference divided by the diameter is always equal to pi. For any circle, big or small, didn't matter. If you knew the circumference of the circle and you divide by the diameter, you would always get this number, this 3.14, so on. And as we've gotten better at measuring things, we've been able to get this number for pi more and more accurate over time. Okay, so here is our circle where we want to label all of those terms that we were learning about a moment ago. So the first word we want to put on our diagram is diameter. To do this, I'm going to need to try and put a dot in the center of my circle where the center should be. And then I'm going to rule a line from one side to the other. Okay. So there we go, from one point on the edge of the circle to the other, that line is a diameter. Okay, the next word is the word radius. So the radius goes from the center of the circle to the edge. So I'm just going to draw another one here from the center to the edge. That line is called a radius. Next word we have is a chord. A chord goes from one side of the circle to the other, but does not go through the center like the diameter did. So this one here, that can be my chord. Okay, a tangent is kind of on the outside of our circle. I might draw it up here up the top. It is a line that comes and touches at one brief point on the edge of the circle and then keeps going. So that little dot that I've drawn is the point where it's just touching. That line is the tangent. Next, we want a sector. A sector is the area that is cut off by two radii. So in here, I had a radius drawn. So that little wedge in there, that part, the area is called a sector. And finally, we want a segment, which is the area cut off by a chord. So I'm going to shade this part down here. That part would be a segment. Now you can actually have any chord, will actually make two segments, a small one, which is the one that I've shaded in, or you could have the other side of that chord, which would be a very, very large segment. We call the small one the minor segment and the large one the major segment. Okay, let's go on to our questions. So in the example here, it says use the formula C is equal to 2 pi r to find the circumference of the following circles correct to one decimal place. Okay, anytime you're doing a calculation that involves pi, you are going to have to round it. So be on the lookout for that in the questions as to whether you're rounding to one decimal place or two. All of these questions in the diagram, we have the picture, the radius is going, we're given from the center of the circle to the edge, which is the radius. So that's why in all of these questions, we're going to use C is equal to 2 pi r, the formula that has the radius in it. So every time you do these questions, you should have 3 lines of working out. The first line, I want you to write down your formula. The second line, you sub into your formula the radius, which is the r, is equal to 3. Now that means that you'll have the 2 pi, and you put a times sign in, so you go times 3. Okay, the third line, you're going to type that into your calculator. And remember, the pi is just a button that you can press on your calculator. So you go 2, then I press the shift button to get my pi symbol, and then times 3 equals, and there's my answer. To one decimal place, that means I want the 18.8, the 4 will round down. 18.8, this is a length, so this will be measured in kilometers. Let's do another one. Question 2. We're going to use the formula C is equal to 2 pi r. That's step 1. Step 2, we sub in the radius this time is 10.2. So it's 2 pi times 10.2. On the third line, we type it into our calculator. So we go 2 pi times 10.2. To one decimal place, that will be 64.1 because the 8 will round up. And this time we're in centimetres for our unit. Question 3, that 7 is a radius, so our formula is C equals 2 pi r. Second line, sub in that the radius is 7, so 2 pi times 7. Third line, type it into the calculator. 2 pi times 7 is 43.98. Because the 8 wants to round the 9 up, we're going to have to round that all the way up to be 44.0 centimetres. Question 4. The 9 is a radius. So C is equal to 2 pi r. Second line, sub in that the radius is 9. 2 pi times 9. Third line, type it in your calculator. And that will be 56.5 centimeters to one decimal place. Okay, so that was using the first formula. In this next section, we're now going to use C is equal to pi d, because each measurement in these questions go the whole way across the circle, so they are diameters. Okay, so the same 3 lines, we're going to start with the formula, which is C equals pi d. The second line, we sub in that the diameter is 22, so it's pi times 22. Remember that things next to each other are always times. So in the calculator, we type in pi times 22, and we're still doing one decimal place, so that will be 69.1 and centimeters. Question 2, C is equal to pi d. This time the diameter is 20.4, so we sub that in, pi times 20.4. Third line, we type it in. Get 64.1 meters. Question 3, the 20 is a diameter, so C equals pi d. Second line, sub in that the diameter is 20, so pi times 20. Third line, we type in pi times 20, and we get 62.8 kilometers. And one more, C equals pi d. This time the diameter is 16.4. So pi times 16.4, and what does that equal? 51.5 and meters. Okay, on to the next page. It says, use your calculator to find the circumference of the following circles, correct to 2 decimal places this time, show all working. The other thing that's different about this question is it doesn't tell us which formula to use, so we have to work that out ourselves. In part A, the question goes from the center to the edge. That's a radius. So that means we need to use C equals 2 pi r, because r is for radius. Then we'll sub in that the radius is 3.5. 2 pi times 3.5. Okay, then on the calculator, 2 pi, oops, I missed the pi button, times 3.5 is 21.99. Oh, because we're doing 2 decimal places, the one after that will round down, so we'll keep the 21.99 meters. In question B, the line goes all the way from one side of the circle to the other, so that is a diameter, which means we need to use C equals pi d. Okay, second line, we sub in the diameter is 4. Pi times 4. Third line, we type it in, which is 12.56, but the 6 after that will round it up, so we need 12.57. Okay, now before we had such wonderful calculators that we could use, we had other approximations for pi that weren't quite as accurate as our calculator. So occasionally you'll get a question that says use the approximation given to find the circumference. And in these questions, the first one says we want to use pi is equal to 3. Okay, so we're just cutting off all the decimal places and we're just using pi is equal to 3. And in the second one, we're using this fraction, pi is equal to 22 over 7. There are a few different things that you can be asked to use as a approximate value for pi, but these are some of the more common ones. So the question starts pretty much the same. We have to decide which formula we're going to use. In the first question, we're going all the way from one side of the circle to the other, which means we have a diameter, and we need c equals pi d. The second line is where the little small change happens. Instead of using the pi button on our calculator, we're going to be using that pi is equal to 3. So we're going to sub in a 3 for the pi, and the diameter is 10, so we sub in the 10 for the d. So we have 3 times 10, which means that the circumference is approximately equal to 30 meters. So using that pi is equal to 3, we get a 30-meter circumference. We know that it wouldn't quite be like that because we know pi a little bit more accurately, but that's what we were asked to do. So question B, let's do another one. This time we have from the center to the edge, which means we are using the radius formula. C is equal to 2 pi r. On the second line, instead of using the pi, we're going to replace the pi with the 22 over 7. So I need some times signs. I need a 2 times, the pi is replaced with a 22 over 7, then times, the r is replaced with the radius, which is 14. Okay, and then we're going to calculate that. So 2 times 22 over 7, and then times 14, it comes out to be 88 centimeters. Okay, but unless you are asked to use these approximations, every other type of question, you use the button on your calculator. Question 3. Find the circumference of the seaweed around the outside of this sushi roll, and you can see that from the center to the edge, which is a radius, is 19 millimeters. So we're going to use c is equal to 2 pi r since we have a radius. Then we're going to sub in that the radius is 19. So 2 pi times 19, the pi is staying in there again because we're going to use the pi button on our calculator. So 2 pi times 19 equals, it didn't specify in the question how many decimal places, so I'm going to do 1. So we'll do 119.4 millimeters. Okay, so that is how you find circumference. Can you please do exercise 3, page 10 through to 15?